All right. Thanks, Tarek. Thanks for coming, everyone. My name is Ranga, and I'm CTO at Avi Networks. And just in case you had any doubts, I'm originally from India. I came here, I'm pretty much fascinated with large-scale distributed systems. Ended up at Avi Networks, which I co-founded along with a few other troublemakers. One of them is here with me right now. So who are we? Avi Networks is a Silicon Valley startup. We have been in existence for about 3 years now, shipping product for about a year and a half. What we do is large-scale distributed proxy or load balancing platform. So today we're going to primarily talk about how we provide this service in the Mesos clustering, but the platform is common enough to be deployed in other bare metal or other cloud environments as well. Just a quick agenda. We will first see what is actually happening, what we need in the new Mesos platform, new Mesos architecture for service deployment. We'll talk about the solution, then we'll talk about how the solution also provides a lot of application visibility and monitoring, and finally we'll see how we use this ourselves to auto-scale applications and so on and so forth. We'll conclude this with a live demo of this as well. Okay. All right. So this is your traditional architecture that we've all known. Still continues to be deployed widely. Monolithic, 2-tier or T-tier, 3 tiers. Essentially everything bundled into 1 or 2 tiers. And this is evolving into this, where your services are being decomposed into fast, flexible, agile microservices. Okay? But in order for us to move from left to the right, we also need service discovery, service deployment, a load balancing. We need visibility, monitoring into what's going on. We need security for all these applications, and we need to be able to auto-scale these instances. So, and we'll see how we do all of this in this environment. So, just to kind of describe the Avi architecture, it starts with a controller. This controller is really like a Mesos master, in the sense that it primarily does all the policy management. It also manages the life cycle of all these little proxies or micro load balancers, as we call them. And the actual work is done by these micro load balancers. We call them service engines, also called proxies or other micro load balancers. These actually run as containers on the host. And these actually perform the data plane and the actual load balancing themselves. Okay? And once the actual traffic starts flowing, then we do collect a lot of metrics and analytics and feed it back to the Avi controller. And that allows us to provide a lot of visibility and analytics into what's going on in the environment. Okay? Just so we understand what we're talking about here. So it's easier for us to think of this as 2 kinds of applications deployed on 2 types of nodes. These are sort of your backend nodes or backend applications. These are primarily accessed from within the container themselves. This would be sort of your applications that reside within the cluster. And then you would have sort of front-end nodes or front-end applications that are visible outside the cluster. Your external client, for example, would be able to access the front-end nodes from outside. Okay? All right. So at the beginning of time, you would deploy the Avi controller as a container. You would come up, you would point it to your Mesos and Marathon cluster. You would discover all the nodes in the environment. You would automatically spin up all the micro load balancers, 1 per every host. And we can deploy these micro load balancers today in 3 ways. We use Marathon for deployment. We can just deploy it with SSH, and we can also deploy it using free. Now, once these are actually deployed, then the controller monitors and controls the full life cycle of this micro load balancer. If something goes down, it brings it up. The new node shows up. It'll bring up a new, spin up a new micro load balancer on the nodes, and so on and so forth. And after that, for every application that you actually create in Marathon, it gets a virtual service of its own in the AVI controller. So if you create app 1, that would create a app 1 virtual service on the AVI controller. And this gets pushed down to all the micro load balancers. If you have 100 hosts or 200 hosts, it gets pushed down to all 100 or 200 of them, and at that point, it's actually ready to start passing traffic. And once traffic actually starts flowing, then these micro load balancers collect a lot of metrics, analytics, feed it back to the controller, which provides all this information for your consumption. On top of that, it also uses this to basically be able to auto-scale your applications. Okay? Once the system is fully up and running and you actually have applications, let's see how traffic actually flows through this. So if you have a client who's coming in from outside, accesses it from the external network, hits a front-end proxy, the front-end proxy now load balances this to all the containers that are running sort of on the back-end nodes. This front-end proxy is typically a full-featured load balancer, so it would be, and we provide all the features that you would need to run a full-featured load balancer, things like SSL offload, SNI, client-side validation, layer 7 rules, data plane scripting, and it's all controlled through RESTful APIs, of course. And once the traffic is actually in and it sort of fans out across your cluster to all the other microservices, then each client talks to its local proxy or a local load balancer, which in turn now load balances it across the cluster to other nodes. So this is primarily done using a WIP, which is almost a don't care. It can just be the bridge IP or it can be a well-known IP. It really doesn't matter. The most important thing here is, of course, the service port. That is what you really need to know to see what service you're actually load balancing to, right? Once everything is up and running and traffic is flowing through the system, you need to be able to monitor the health of all these nodes. So this one's usually could run into a couple of scale issues depending on the size of your cluster. If you have all your load balancers hitting all the containers, then there's just a lot of load on all the containers. So you don't want that to happen. If you instead have one dedicated node just doing all the health monitoring, that could become the choke point for hundreds of thousands or tens of thousands of nodes. So what we do is we have the local load balancer performing a health check on all the containers on that node. In addition to that, we also have one or a few outside load balancer perform health checks on these nodes. And once a node is detected to be up by all the health checkers, then it's really marked as up, and this state is just synchronized across the cluster, and it's ready for traffic. Similarly, if a node is really, it starts failing health checks, that state is synchronized across the cluster as well, and the node is marked down. So that way, you don't lose traffic, you don't lose sessions by sending it to nodes that are actually down. And it also scales with the cluster size as well. Okay. Any questions so far on how it actually traffic flows through the system or how it gets deployed and so on and so forth? Sure.
So I made the assumption that the controller, when it boots up,
Yep.
talks to Marathon, finds out which apps are deployed,
Yep.
and then auto-creates services.
That's entirely correct.
Is there a way, so for example, us, we use Marathon in a way that there's a split between apps,
Yep.
background units,
Yep.
that run and do
Sure.
things that don't need to be publicly accessible.
Yep. Yep.
How would we have services that only run for the apps in that group?
Perfect. Yeah. So the question is, if services are created based on apps getting created in Marathon, if there are a group of apps that don't need any proxy services, that are just either single daemons or some things that are infrastructure services, how do you bypass them? So all of this is done primarily through Marathon labels. So you can actually label a proxy as an app as saying don't create a proxy for it, and it'll be completely bypassed. Similarly, we also use labels to program all the policies and other configuration for the virtual service also. You can specify things like the load balancing algorithm, even a point to an SSL certificate. You can specify pretty much the entire virtual service configuration through labels. So we use very example.
So like you can have, it sounds like it's only blacklisting things or not, or can you do whitelisting? Like, oh, I do want proxy for these services.
Sure. So you can do that also with labels. You can also tag applications saying, well, this is actually a front-end proxy. So it gets this whip, and this is actually a back-end proxy. So you can do a lot of things using labels. Good question. So once system actually starts functioning and we start having traffic running through the system, we collect a lot of information about it. We tell you what are all the microservices that actually talk to each other. Things like what's the latency that you see across that. So essentially an app map with all this granular information about things like latency, request per second, sessions, throughput, and so on. And you can look at it from different points of view. You can zoom in and zoom out, and you can look at it from an entire application and its constituents point of view. You can also get a lot of details about an individual application. So if you can zoom into one application and you can pretty much look at all its transactions or its end-to-end timing. We'll actually see all of this in the demo. So I'll hold my horses and I won't steal Gavin's thunder. The next step is once your application starts running, we want to be able to actually auto-scale the applications. So how do we do this? So we're constantly sort of baselining the load on the system. So we build a baseline based on the load. In this case, at least one of the most common indicators of load is the number of connections that exist in the system. And the other aspect of this is the capacity of your backend server. So we deduce the capacity of your backend servers based on your latency profile. So we kind of monitor the latency of the application at a given load point, and where it starts to sharply fall off, we say, okay, so this is the capacity of the application. Now, at any point, you have a load and a predicted load. Let's say a load that's going to be there half an hour or an hour from now, and then you also have a capacity. If your capacity is below the load, then essentially it's time to scale up the system. We talked to Marathon to spin up more nodes, and it's the opposite if there's excess capacity in the system that's much more than what the load really needs. And most applications in real life actually follow a very nice pattern. Either they are heavily used during business hours or not, and so in reality, this makes it a very efficient use of your infrastructure. Any questions? Sure. Go ahead. Yeah.
So you measure the load over a period of time, and is that period configurable?
So we measure the load and the capacity. We're measuring it constantly, okay? And so we're measuring it at 5-minute increments, 1-hour increments, 1-day increments, and so on. And based on that measurement, we are constantly creating a baseline profile. So based on that, we can predict on Monday morning at 9 a.m. what is the predicted load going to be, right? So if we can predict that, then at 7:30 a.m. we can actually spin up more nodes and be ready for the load when it picks up at 8 a.m.
Okay. So then you can configure how much time for the predicted scale out need.
That's right. Yeah. So
Can you repeat that?
Yeah. So the question was how configurable it is. The intervals. So it is very configurable. You can configure the intervals. You can also configure the number of actions that the system takes. You can say, don't do more than some scale up or scale down in a given period of time. You configure cool-off periods as well. So it's pretty configurable. Okay. For no other questions, I will pass it on to my colleague to do a live demo. He was foolish enough to accept that.
Sure.
I need to turn it.
I'm sure demo gods predicted a number of years before that. Just today would be the day we would demo Avi and Mesos fair.
Turn it on. There's a button on top. On top, yeah. Press that button.
top?
Yeah.
Oh.
Turns green.
Your part, if you turn it,
Okay. So today I'm going to demo all the things Ranga had talked about, where we would take a system where there's a default instance of Mesosphere running, and we'll create a cloud AVI integration into it. We'll bootstrap the AVI solution, and then we'll actually go ahead and create applications, run some traffic, show the analytics, and also do a demo of auto scaling. So the first thing I'll probably have to here. All right. So we have seen this slide before. I just want to walk through a little bit about the demo setup. It's going to be, so we have, like I said, a Mesos Marathon instance already running, and we have a Docker registry which is used for our micro load balancer image management, and application images are stored there, container images. And we have an AVI controller which is running with no cloud setup on it. So as part of the demo, I'm going to set that up. And then in the bottom, you see the backend nodes Ranga talked about. There are 40 of the Mesos nodes here, which are used for instantiating east-west application or the microservices. And the blue box over there is one single node, which is used for instantiating the north-south container, which are used for facing the external traffic. So all the containers which need to have external access will actually be instantiated in the blue box. So with that, I'm going to fire off the cloud setup. So in the interest of DevOps, a lot of this happens via scripts, but there is no black magic here. I can show the API.
That's an infinite loop there.
All right, I got to my screen where I wanted to be. So essentially, here's our AVI API, and previously there wasn't anything. Now it got configured to the Mesos, all the settings there. And I'm going to go back and show what things we actually did while the script takes to configure. So the first thing we did was when the AVI controller came up, it was configured with a Docker registry URL, and in this demo we are using Fleet, so we configure the Fleet URL. And what AVI controller does is it actually programs the Fleet with a service engine or micro load balancer container image. And then it takes the Mesos URL to fetch all the Mesos nodes that are present in the system in the cluster. And it will go and instantiate micro load balancers there. So to start with, here is my controller, which keeps logging me out. And we can go and look at the infrastructure tab, and there are service engines actually. As we just speak, new service engines are coming up. So going back here, then it also, like Ranga talked about, we use for the orchestration of the micro load balancer, we are using Fleet for the demo, and then we have Marathon URL, which AVI controller uses to learn all the applications that we created in Marathon. And when they are created, it brings those applications into AVI controller and creates the listeners for distributed proxy that are going to be used for load balancing traffic for each of those applications. And then lastly, we have support for two types of container IP address mode, which is native and routed IP. In this demo, we are using the routed IP version. So coming here, okay. Second. So what really happened was cloud configuration was pushed to AVI controller. It pushed every image to the Docker registry, made a query to get the node list, provisioned all the micro load balancers on each of the node. So that happens once. And then for every north-south or front-end Mesos node, it is going to create a little bit fatter service engine, because these nodes are expected to carry more traffic than other. Going back to my demo, Here it's the live controller IP, and here are all the list of.
Can you present again? So if you, on the green button, present to everybody.
All right.
On the,
In the top right.
yeah, top right side.
This one.
Yeah. Yep. For some reason it
Oh, okay.
stops.
Top left side. So here's the list of all the service engines, and let me check if the cloud configuration is done. Yes. So at this point, the Mesos cloud is ready, and with the micro load balancers, and we also have a front end, and we're going to now go create application. So here you go. So at this point, there is nothing, and you can see that on the Marathon UI, all the applications are getting deployed one by one, and it's going to take some time. So I'll walk through what happens during this time of the deployment. So what we have done is we have created a photo.com application, which internally talks to 16 microservices. They are spread across 40 different Mesos nodes. And our controller, as it learns the applications in Marathon, it creates the proxy distributed proxy listeners in the Mesos environment. And when the traffic happens, like Ranga has talked before, if the blue application wants to talk to, let's say, a green one, then the traffic will be initiated to the service port corresponding to the green application, and it would get load balance to the right instance based on the algorithms used for load balancing. Let's see if all my applications are up. So here it looks like most of it is running. And at this point, I'm going to start sending traffic onto them. Actually, traffic is probably already going. So on Avi controller, each of these applications will show up in form of a map. I'll search for it. So here you can see it's probably going to take a few minutes for the traffic to go over it. So here's a list of all the apps. So there is one-to-one mapping between right now what is in the Marathon. Unless we would have used the labels that you had talked about, there will be one-to-one mapping on Avi and there. So here you go. So this real time, essentially, map gets created based on how different microservices are talking to each other. So every edge signifies a traffic between two services, and the nodes signify a given microservice, whether it's a north-south or east-west. And the number on each of the nodes is the health of that microservice. So as an admin, if you're looking at the whole application, this is a 1 second you would know what's going on overall on your application map. And there are certain problems you can actually build on to one of them. And the nodes themselves are of different sizes, which gives an indication of how much scaled out they are. So not every node is going to have the same traffic profile, and the size of the diameter is dependent on how many number of instances or tasks each of the apps are running. So let's say we go to usersphoto.com to find out, like all of them are actually, the health has changed based on the latency. So let's say as an admin, you want to find out is like what is going on with photo.com, and it's getting 246 millisecond of latency, where it is coming from. So you can look at, in a very quick instance, like what are all the apps this user's photo microservice is talking to, and what are the apps or applications it actually receives traffic from. So in one instance, you can get an idea of how the traffic looks like. And all this is being done in real time. So you can go back in time to see how was the traffic pattern like 1 year in an aggregate, or 1 hour ago, or 1 week ago, and on real time what's going on. And as Zoranga had pointed out, at this point, let's say there was some problem going on, you can drill down to very detailed level analytics on every microservice. So you can see the end-to-end profile, like how much time it is taking to serve requests. You can look at other performance metrics like throughput, look at connections. Let's say somebody actually is complaining that they are not able to find their photos, and you don't typically get those requests from other people. So health and performance metrics that aggregate may all look pretty good, but there are a few people who are complaining. So you can actually come to what we call a Google-like search for anomalous transactions in the system. And there you can look at each and every transaction which actually didn't meet the SLA. For example, this one, it took 5 seconds to respond back, and you can come here and look at why was this 5 seconds, and which container instance was used to serve this particular transaction. So even though everything is distributed, Avi makes it very easy to find the problems, what's going on in the system. So another thing is, which I probably should have talked before, is like, as even in the distributed environment, all the policies are always synchronized across all the instances of micro load balancers. So it doesn't matter where the traffic is originating from and which web or which microservice it is hitting. The behavior you would get from the whole cluster is uniform, and the policies are always enforced. So let's go back to, so I think next I'm going to demo the auto scale of, so I think let me make sure. So next I'm going to cover auto scale. So one of the apps in this whole complex is auto scale. So let me search for it. Okay, I need to create that app. Second. Okay, sorry. So in Mesos, we just created a new app, a Microservices app. So what I'm going to do is, this is a new app, and I'm going to, normally we would have a baseline, like Ranga talked about, of the traffic profile for this app. And we would bombard it with traffic, and we'll let it scale out as the load on the app increases. So let's say some traffic to this app, and we'll go to the app here, scale. So in real time, we can see how the traffic is flowing on this. So you can see the traffic just started at 59 Mbps, and open connections like 400. And what this app was configured was, and this is one of the things, is like, not every application is going to fall in the same template. So we have an ability to select what kind of auto scale policy we want on it. And this is set up to be an intelligent auto scale policy where we use the predictive load and the estimated capacity of the application. And normally when we talk about capacity, what we saw was the state of the art would be, we take a look at the CPU and we say if CPU goes above 80% means it's getting overloaded, or memory is very high, it's getting overloaded. But that actually in practical life doesn't work out that way, because applications and software, they are complex things, and saturation happens at a very, very different level. So we wanted to be able to use our analytics that we are getting here to essentially smartly determine when the saturation is going on in the application. So we, like Ranga had talked about before, that we actually look at the application's performance, and just by the fact that it is serving requests is not good enough, but we need to know that its performance actually is changing with the load. And when we see a significant deviation from its traffic profile, that's when we say, oh, it's getting saturated, and now is the time to kind of auto-scale this application. So from a application perspective, they're typically not just a single instance of it. There would be, let's say, 10 instances. We would look at, in real time, capacities and load across all those 10 instances. And when we know, our micro load balancer knows that it is running out of capacity aggregated across all those 10 instances, it will make a determination, not just like one instance getting overloaded, it's going to trigger an auto scale. And so to the point earlier made, like there are different settings you can do, like cool down period. You can have an adjustment step, like in one go, how many instances you want to increase, and those are all the things set up. And what is not shown in this UI is also we also support the traditional mechanisms of, like, if you want to have CPU and memory just to keep to be able to sleep at night well, all that is also supported. So those things are also there. Let's go to this app and see on Marathon. It actually has gone from 1 to now 3, and it has essentially scaled out like 2 times already. And for an admin, we make sure that some of the information, these scale out events are properly represented, and you could have alerts when the scale out happens. And I'm going to actually go ahead and kill this application so that the scale down happens as well. So it typically takes like a minute for it to react, given the inertia built into it. So that's kind of all the demo for today.
Okay.
If there are questions or anything you would like to go back.
So,
1 second. I can give you the mic.
I actually have 2 questions.
Sure.
First question, on the first slide, you mentioned service discovery. When you register a service with Avi Networks and the controller, is there some mechanism for other things that want to consume that service to actually discover the BIP and the port in order to connect to it through the service engines?
Sure. Yeah, great question. So there are actually 2 ways you can do that. So you can just create an application in Marathon, and which gets a service port. And in that case, I think the entry also gets dropped in Mesos DNS, and your application can actually look up a server record from Mesos DNS, and we will simply use that port. Okay, so we will simply synchronize that information from Marathon, use the exact same service port that Marathon is allocated for that application, and traffic, you can just start sending traffic to that service port. For the
It's a different IP.
So the IP itself can be the bridge IP. The IP actually doesn't even matter here. It can be the bridge IP. It can just be a IP that you use globally. This is primarily for the so-called east-west services. Okay. For the north-south services, so there are 1 or 2 ways you can do this. We currently support integration with an IPAM, Infoblox to be more specific. So when you create a front-end proxy service in Marathon, and we indicate to Avi that it's a front-end proxy service, we can actually talk to Infoblox, allocate a public IP, for example. I'll also program a DNS entry in corresponding to that WIP, and then at that point onwards, the traffic will be, we can start serving traffic on that WIP on that port. So it becomes a publicly available traffic. If you have some other IPAM, then we have to do a little bit more integration, but it's really sort of an adapter per IPAM, so we can plug in a different adapter, if you will, to allocate a WIP and also drop in a DNS server. Right?
I had another question, but
Sure,
I'll
please.
surrender the microphone. What's the performance overhead of all of this ride? There's a lot going on.
Yes.
How much CPU, how much RAM are you burning up
Yeah,
with
yeah,
each
yeah.
of your nodes for this?
Yeah. So by default, we have seen that even a single core is good enough for at least 3-4 gigs worth of traffic through the micro proxy, and it's good enough for about 2,000 SSL transactions per second. So typically we just recommend deployments with single core for the east-west micro load balancers. For the front end or the north-south, it would be probably 4 cores or 8 cores, because that's where you terminate most of your SSL. So that's typically how most of our deployments are.
Cool, thanks.
Okay. All right. Thank you. Just a few concluding remarks. We'll just wrap it up. All right. So I'm just going to skip over. Yeah. Okay. So this, you can deploy this on essentially in AWS today. You can spin up a Mesos cluster in AWS along with Avi. You can go to the website and you can just deploy it. You can also deploy it in your on-prem cluster as well. And again, like you mentioned, it can be deployed either in a native mode or in a routed mode. And we have some other SDN integration as well. And today we pretty much integrate with a lot of partners and exist in a lot of ecosystems. And it's free for developers. You can continue to use it. Please contact us. This Slack channel, just go to our website. We do have families and we have children, we need to feed them, so we also charge money for production. Right? And other things we're working on things more about security. So essentially you can say just app A is allowed to talk to app B, and we'll lock it down. No other apps are allowed to talk to app B. You can also say just encrypt everything in the fabric, and without changing any application or anything, we'll take care of encrypting everything else on the wire. Also, working with other orchestrators and so on and so forth. And of course, we're hiring, and please feel free to ping us if you're interested in proxies. And just go to our website, and essentially you should be able to get all the information. Contact us if you need anything else. Right. Thank you. Any questions?
Any questions?
Yep. Go ahead.
We have a microphone.
You mentioned that the only IP access management that you support right now is open blocks. Is that you said?
Info blocks.
Are you going to support like Elastic IP, AWS's Elastic?
Sure. So actually, it works kind of out of the box today in AWS. So you can deploy, you typically deploy it with the Mesosphere CloudFormation template. We have taken that template, and there's a template in our website today, which has the AVI added on top of the Mesosphere template. So you just deploy it, and out of the box, it would come up, and AVI would be installed on it. And then you can actually use the public slave DNS and the Elastic IP and start load balancing to it. So the north-south entry point would be ELB, and then from then onwards, it would get load balanced throughout within the cluster using AVI. Yeah. Good question.